Welcome back. This is Mr. Hassan's Maths channel, and this is question number 7 from the Solomon D C2 papers, which is also question number 2 from my P2 Pure 2 end of topic worksheet for chapter 5, which is about sequences and series. I'm going to do 7B as a separate video from 7A because I think I've already answered 7A in some other places, which is all about how to prove the sum of the first n terms of a geometric sequence. So this question here is asking us to evaluate the sum of all the terms that are generated when you replace the integers from 1 to 12 instead of r in this expression and add them together. That's what this basically means. This means the sum of, and you replace the numbers from 1 to 12 instead of r in this expression and add them together. So if we start doing that, we can start doing that by saying that this is equal to, let's start with the first term. We have 5 times 2 to the power of 1. Then you have to add to that 5 times 2 to the power of 2. And you keep going, 5 times 2 to the power of 3, until you reach the last term, which is 5 times 2 to the power of 12, from 1 to 12. Okay, so we've got to find the sum of all of these terms. So you've got to think to yourself first, what is this sequence that is being generated? Okay, now this is a sequence which looks very much like a geometric sequence, where you have a common ratio of 2. If you divide each term with the term before it, you're going to get 2. If I do 5 times 2 squared divided by 5 times 2 to the power of 1, the 5's cancel out, and you're left with just 2 squared over 2, which is 2. Similarly, this term divided by that term, the same will be for all of them. So here we can see the first term in this sequence is 5 times 2 to the power of 1, and the common ratio is 2. So we can see here that we can use the formula which they gave us in the first part of the question. It's in the formula book that you should know, but the formula that we have to use is to do with the sum of the first n terms. Okay, and now we're talking about a geometric sequence. So it's given by a times, and if r is bigger than 1, then this is the better formula to use, r to the power of n minus 1 over r minus 1. If its magnitude was less than 1, it would be better to use this form of the same formula. Okay, but this is much easier to use when you've got r as a number which its magnitude is greater than 1. All right, so now that is the formula for the sum. There's another formula, un equals a r to the power of n minus 1. Now that is to find a particular term. Here we have to find the sum of all these terms, to add them all together. So we're going to use this formula to do so. So we have the sum of those. Now here we know n is equal to 12. We have 12 terms, 1 to 12. Be careful about this, because sometimes they might start, for example, if they said from 2 to 12, many people will write down 10 as the number of terms, but from 2 to 12, there's actually 11 terms, because if you subtract 2 from 12, you're going to get 10, but you add 1 to give you the number of terms. 12 minus 2 gives you the number of spaces between them. Just like if we did 12 minus 1, we get 11, but there's 12 terms, of course, from 1 to 12. So when you have the numbers which don't start from 1, be careful. Don't just subtract them, add 1 to your answer, and you get the number of terms. So in this case, it's not a problem. It starts from 1, so it's kind of something that you don't really have to think about too much. But if you did subtract them, you would get 11. But there's actually 12 terms, because when you subtract, you get the number of gaps, not the number of terms. Okay, so S12 is equal to A, which is 5 times 2 to the power of 1, which I'll write the 1 there, multiplied by 2 to the power of n, which is 12, minus 1 over, we're going to have 2 minus 1, which is going to give you 1 anyway. So that's going to be 10 times 2 to the power of 12 minus 1, which gives us, we can just stick that in a calculator, we have 10 times 2 to the power of 12, and then take away 1, and that gives us 40,950. And there's your answer. Very simple. Okay. Just have to understand what this terminology means. Sigma means the sum of, Okay, all the terms generated when you substitute the number down here into this, and then every integer until you get to the end one, the last one, which is 12. You add them all together, so you generate the first few terms to see what type of sequence it is. It's definitely a geometric sequence, so you have to use a formula for geometric sequences. Mistakes that people make, they use the formula Sn equals n over 2 times a plus l. No, this is like n over 2 times the first term plus the last term. This is only for arithmetic sequences when you have a common difference. So you don't use that in this case. That's a very common mistake that people make. And also some people, they don't try to determine what type of sequence it is. They just take a guess, and sometimes they guess wrong. How do you divide a term by the term before it? Okay, a little side point as well. We could actually do this question by writing the 5 outside the sigma if you wanted to. You can write this as 5 times the sum of the terms from 1 to 12. And, this will be 5 times 2 plus 2 squared plus 2 cubed plus, and so on. You see that in the end, the answer was just going to be basically 5 times all of this. So it'll be the same thing. That and that are the same. That might help you in other questions later on. Okay, but that's a little side point. Anyway, there's the answer to question number 7, part B. Pretty short. I hope that was clear. One of the students in class asked me to answer this for them, so I've done so. Thank you for watching. Other questions from this particular paper, when I get around to answering them, will be in the playlist over here. Other questions from sequences and series from P2, you'll find them in the playlist in this area over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.